Happy New Year.
Hey, Steve. Happy New Year to you too.
Did you have a good holiday?
Yeah, it was so good. I did pretty much nothing on this competition in the 2 weeks. Other than, in fact, I'm kind of somewhat frustrated or disappointed. I don't know which combination, disappointed in myself or frustrated with it. I mean, I tried to go through your notebook and even trying to understand what the hell was the way that the scoring is done left me quite confused. I don't know whether it was me just not wanting to engage during the holidays or what, but I was very confused about the whole, why do they use, I forget, 3,750 or the 16 and how all those things work.
Yeah, no, it's like they've got some bizarre stuff. It took me a while to go through. Yeah, like in terms of calculating the values or whatever, it's a bit strange how it's done.
Yeah, because, I can understand one part of it, which is, okay, so you take, the last 16 data points and use that to predict the last 15 to predict the 16. But then what is this 3750 and where does that come in?
Yeah, no, that's just their evaluation metric for, don't know how they picked that number, but yeah. Yeah, so it's basically you just have to add up like the 3,750 rows or whatever to work out their values.
And then how does that enter into the equation again? I forget. But anyway, that's what I was like, man, this is way too complicated to just even get the score figured out.
Yeah. So, yeah, so like I just sort of took mine from like Guy's notebook or whatever, who had like sort of worked out how they were working the values out.
Yeah. There were like these two that you had pointed to, and you had all these functions in the notebook which were pretty. I mean, you could go through the code and figure out what it was doing. That wasn't the complex part, but stepping back and understanding the concept or what was being done was for me just ridiculous. I don't know whether it was just me or. Anyway, I think people have joined. So were you able to make progress on it and get somewhere or?
Well, sort of eventually, yeah. So like it took me days and days. I'll share my screen here and show you.
Yeah.
Yeah, so here's the submissions I've done. So the first one here is like a score of -1. You see that? Yeah, so like that was just submitting, I think that's just submitting zeros for everything. And then this one here, there's 004. This was where you just like take the median value of each asset and submit it. The point of this was the fact that this confirmed that the function to work out the score locally works. So like with this notebook here, like when I ran it locally using the median value, it gave me 0.04, and then the competition submission did as well. Then like the last time we'd spoken before Christmas, yeah, like I was having like loads of problems with just like sort of the time it was taken to, and because of the fact you get like one new time step per pass of their like evaluation function. So like I need to add that in to like let me keep updating the sort of the training data as we go. And yeah, so like the last time I had like a lot of problems just getting things to fit in with whatever it is their 9 hours of time. So you can see here, like I just went through a stage of massive amounts of like submitting and getting errors. And the trouble is,
I went through. I wasn't as persistent as you were, so I kept getting errors for any method that I was, any time series method I was using, and I couldn't figure out until I think in the last call before the holidays, you pointed to the work you had done to duplicate the scoring, right?
Yeah. Yeah. Like the trouble is as well, you're only allowed to make 5 submissions per day. So like here, I was like trying, and by here, I'd run out of submissions. So the next day I had to start again. So like it was like starting again, and like here's back to sort of just like submitting zeros again. And this went on for about 4 days or whatever. Like you can see, it's just one after another of like rubbish submissions, either like failing. And eventually I got through. So like eventually it was yeah, like I just had to sort of make sure I was not having any errors in my submission, like making sure if you've got like any not a number of values in there in your submission as well, it seems to throw an error. Additionally, like if you have any values that are like too big or too small, it tends to throw an error. So like I put stuff in to make sure that all of my values are between sort of plus and -1. And yeah, so like eventually I got through. And then, yeah, so like this was my final one. So this one here, so the way my notebook, I'm not sure if I can show that. Yeah, so like there's just like all the data loading for like the main stuff. Yeah, so like I have like this class, and basically like the value that they use, as we were talking about there. So the value is, it takes 16 time steps into the future and like divides that by the next time step to get like a closing price ratio. And then, yeah, like then averages back over 3,750 time steps or whatever. So like there's loads of like notebooks that are in like the public leaderboard at the minute. They've all got a near perfect score of, yeah, very close to 1. They're all sort of sitting at 999. And like all that they've done is basically they've just taken the values from the training set and used it for the public test set, because we know what dates that is. Whereas in my case here, what I'm doing is I'm actually taking the closing prices, and yeah, so you only need to like get the closing prices 16 time steps into the future. As we said, like the ratio is the 16th one divided by 1 time step in the future. So all you need to do is like predict for 16 time steps. So here what I'm doing is, rather than taking the value from the competition, I'm taking the closing prices, and then I'm using the function that I showed like a while back, like that guys used, where you can like calculate the value from the closing prices. And like that's how I ended up with that score. So like this score here, yeah, like it's pretty close to 1, but it's not using the values out of the training set. It's using the closing prices and the formula to work out the value. So like it means what I can do now is sort of, yeah, just try and predict closing prices or the ratio of the closing prices rather than having to work with those values. So like that was the last notebook I'd done. But again, when I ran this, my local evaluation gave me exactly the same score. So it shows that my sort of like local evaluations are working okay.
As I understand it, what you've done is it's the problem of prediction of target values, which get the appropriate score, to the task of predicting closing prices, and the rest of the logic from closing price prediction to scoring is flushed out to be and proved to be equivalent.
I think so there. Sorry, I was having trouble hearing what you said at the start.
Oh, yeah, no, I was saying you just, by doing the problem of predicting target values to closing prices, and then you have proven multiple times that closing price to target values and scoring is exactly as the competition specified. So now the only task left is using some time series method to predict the closing prices.
Exactly. Yeah. Yep. Yeah. So like since that, yeah. So like now I've moved on to that. So I didn't know anything about time series prediction. So I've just been like working through sort of tutorials and things and looking at sort of basic time series prediction stuff. So like it's whatever like sort of classical models are. Yeah, so like here.
Yeah, in fact, I spend most of my time, in this part, and I still can't figure out the scoring part. So I'll go back over this next coming week to look at your notebook, and I started that, but it was just maybe you can again touch on like the 16th ratio. At least I get somewhat right, meaning you factor in 15 or 6. Is it 15 or is it 16 values?
It's
1.5 or 1.6.
The ratio is actually formed from one time step ahead divided into 16 time steps ahead. So I think it's like 15 time steps, but one ahead and 16 ahead. So it's like t plus 1 and t plus 16.
And so the ratio of t plus 1.
Sorry, it broke up again there. I'm not sure, is it your connection or mine?
But... Oh, sorry. Is it t plus 1 to t plus 16 or ratio or?
I can't remember. It was in that notebook I had before.
Okay, no, never mind. Okay, but what is this 3750 or 3570 or whatever? Where does that come in? That's the part that I have a hard time fitting in.
Yeah, like again, that's within their formula. Yeah, so like here, the price ratio, as you can see here, so well, this deck thing's like 16 big, so it's the last one of the deck, and the first one of the deck gives me the price ratio. But then to get like the value, yeah, like they take, yeah, like a rolling sum of the last 3750 rows. Yeah, I don't know why they chose that, but that's just what they use for the competition metric. Yeah, so like this is the weighted average. Yep.
In your submission notebook, does that mean at any time you only have 16 samples stored in the memory?
Yes, sort of. Yeah, so you've got all of the training data. So you've got the training data up to the time step that you're trying to predict, and then I need to predict 16 closing values into the future. So I've just got like this deck structure which contains 16 closing prices for each asset for the next 16 time steps. But then because of the fact that you need to have 3750 to work out the value, then I append those like on each step onto the training data. So my training data at each step of the evaluation gets one more set of data, one more time step.
Okay, so the only reason that you load the training data is because you need the 3,750 samples.
That's right. Yeah.
You're not actually doing any training.
Submission notebook. At the minute, I've just like sort of started on that. So yeah, like I've just been looking at. I'm not sure if you've seen this like VAR, which until like last week I thought, yeah, like it's vector auto regression or whatever. And with it can sort of use regression to try and like work out the relationship between, so here, like each one of these columns is one of the assets. So like that's Binance coin, and I think that's Bitcoin. So these are their price ratios, and this is like a graph of the price ratios over time for all of them. So you can see they sort of go up and down together, those ratios. And like with this vector autoregression thing, you can like train it with some of like, so here you like make a VAR model, and then this training set. So like here I'm using the training data there. So I'm using the price differences get stuck in there, and this model is fitted to that. And so from that, then I'm trying to predict. So you can see here, like this is like for one of the assets. So like the blue is how it like sort of goes for the next 16 time steps, and my yellow one's the prediction. But yeah, I've just sort of started playing with that. So like here again, like
it's a quick question, Steve. Is the VAR model univariate, meaning you predict per asset and then just do it 16 times, or is it a multivariate thing where you can predict all 16 at the same time?
It's
or
multivariate.
14 or whatever the number of assets.
Yeah, like that's the good thing about it. It's like multivariate, and so like there's like loads of other stuff in it where you can like do all, like I didn't know about stationarity and whatever.
Mm-hmm.
And like there's these causality tests to sort of show if there's correlation between the things. So like VAR, it's sort of is multivariate, and if there's relationships between the different time steps, then it takes those into account. So like I've only started working on this, so it's
and so does that mean in the submission notebook, whenever you get a new test sample from the API, you would call that fit function again before calling the predict function?
So
to predict.
so as I say, I only sort of started doing it. So here, so like this is using some training data, like it's got 500 bits of the training data, and I've just like split it into a training and a test bit. So here it's making like the VAR model with the training data, and then it fits on that, and then it makes a prediction for the next 16 time steps. So like that gives me my first set. And then because of the fact in the competition, you get one new piece of data each time. So like this loop here is sort of simulating that, where the training data grows by one bit of information on each loop. So like in the make prediction thing, so like this is the VAR model. So here, the VAR model, it takes the last sort of training steps, and then here, like this is the number of steps it'll predict into the future, and like that creates me a forecast here for all of the assets. So like it gives me in this case steps is set to 16 because I want to predict 16 into the future. So it'll be 14 for the 14 assets by 16. But it is possible. So here, like this is using the model that was trained previously. It would be possible to like retrain the model as well every time, but I don't know enough about VAR.
But that would mean you'd be training on your own predictions, right? You're saying like you make a new prediction and then you fold that new prediction into your training data and then train on that.
I could do that. What I was going to do though was, as I say, because of the fact that in the submission loop for the competition, on each pass of that, you get one more piece of data. So I was just going to expand the training set by the true data and train on that, rather than, like it would be possible to train as well on the predictions, but I'm not sure. The only thing about it is VAR, it does like seem really fast, but yeah, like, so you can see here, yeah, like here, it's fit the model in 0.4 of a second, as well as doing these other bits and pieces. So it is pretty fast, but like, whether it's fast enough to be able to retrain or refit every single sort of pass of the competition submission, I'm not sure.
But
yeah, so,
Steve, there the issue, as I understood it, I may be wrong, so it's more a question, but let me comment as a statement first, is my understanding, at least of the API, and which was the thing I was somewhat frustrated by, is the current API doesn't let you have access to the future real data as time moves.
that's
therefore, right, therefore, the only option you have, or we have, is to use predictions as if they were real data in the future. Because the thing that I was somewhat disappointed is actually it is because once the future data is available and you've already predicted it, I thought it would be okay for them to expose the real value once you have predicted, because all they want to ensure is that you're just not predicting that value as after having seen it. But they don't do that. They hide the future values forever. So it's only the fact that you can only use your own predictions as future values. Am I understanding that right?
Well, sort of. So yeah, so like on the day that the competition starts, there'll be like a set of training data that goes all the way up to that start date. And so like it'll have every training value for that. And then your notebook will run inside their evaluation function, and they'll give you the next set of closing prices for the first minute at the start of the competition. So like at that point there, you've been given like one more time step of training data. So you can add that to the training data you had. And then you need to predict 16 time steps into the future. And then you'll go to the next iteration of their competition loop, and it'll give you like the next time step of data. So again, you can add that to your training data. So you're always like 16 time steps behind the point that you want to predict. But on each loop of their data, you are getting more and more data that you can use for training. So like that's why I said in this loop I'm showing here. So I start off with just the basic training data, and then on each loop, my training data expands by one time step worth of data. So you don't actually need to predict on your own predictions, or you don't need to use your predictions for training, but perhaps you could.
I see.
Yeah.
So each time step, the next time step data is available.
Yeah. So each loop in the prediction thing will give you one more set of data, or one more time step worth of data. Yeah. So these are like my predictions now using this VAR thing. But yeah, so mine's the red line and the true thing's the green line. But I think I'm cheating slightly. I think I pulled it back by 16 time steps or whatever. So I don't think it's as good as it actually looks there. But yeah, like now all the notebooks working and stuff, my problem's like sort of simplified down to I do just need to predict 16 time steps into the future on the closing prices. Hopefully sort of get somewhere with that.
Yeah, and 16 is small enough. I think that's the other thing, right? It's like what you're doing is every time step, you're just predicting 16 time step ahead rather than trying to predict on for the entire 3-month duration with all the data that you have, right? It's like each step you predict 16 steps forward. Each step you predict another 16 steps forward, right? So in effect, you're predicting 16, but moving one time step at a time forward, correct?
That's right, yeah. And yeah, so like, as I say, like that seems to be the good thing with this, like this simple VAR thing. So it's multivariate and it seems very fast to train. So like potentially I could keep fitting as I get more and more data, I can keep fitting with the new data. Whereas if you use like something more complex, like, you know, like whatever it is, Facebook profit, supposedly like it's really good at sort of predicting into the future, but it takes like a long time to train. So it's not good for sort of like online type of time series
prediction.
Yeah, because of the fact that you don't have enough time to retrain it all the time. And I was reading about a thing called drift or whatever, where there's sort of calculations you can run to sort of work out if your model has drifted too far from what the data is doing now, in which case then you can sort of fire off an event to tell it to retrain. But because of the fact it is such an expensive operation to retrain it, you can't do it on every iteration. You only need to do it, yeah, like, I don't know, say some like new regulation comes in for cryptocurrencies or whatever that sort of massively shifts the market, then in that case you would sort of detect that and retrain the model at that point. Whereas in my one here, it's just sort of, it is just basically a moving average that's sort of following, I think.
Cool.
So.
Anyone else want to chip in or chime in with what they were able to do?
Yeah, I did something. Just I'll share my screen. Yeah, so like I decided to go for this long range transformers, which I saw of, I think Steve shared a Medium blog post about it in the Slack channel. So I quickly skimmed through the paper, and it's got the code is in this GitHub repo. So I was able to adapt the interface for this competitions data. And so I quickly just made some predictions using an untrained model. And so it kind of looks like this. So like for each samples at present, so the data that's input into the model is kind of split into 4 parts. Sort of the context period, which are the samples based on which you want your model to make a prediction in the future, which is the target period. And yeah, so these are the predictions from an untrained model on all the assets. The red lines are the predictions, and the blue solid lines are the ground truth target values. And at the moment, it only takes in features derived from the time label. So it's like the year, the month, the week, the day, the minutes. And in total, like there are six features. So the model makes a prediction based on 6 input features and outputs target values for the 14 assets. And so after So after getting it to make predictions, I tried to quickly write up a submission notebook, but so far I haven't had much luck. Let's see. I'm kind of running into a notebook exceeded allowed compute error, which I suspect is due to sort of out of memory error. And yeah, so I'm still trying to figure out where I'm sort of using up too much memory. And yeah, so that's sort of where I got to. And so some of the problems.
By the way, Jack, this is where what Steve was sharing before the break, just before the break, and what he shared in the first part of what he spoke about, I think is critical, because the same kind of erroring out that you saw him show, and basically his approach to ensuring that locally you get the same score as what you would get when you submit is the only, so far in all the notebooks I have poured through and looked at, his approach or Steve's approach that he said is the only thing that consistently seems to get a score, and also get a score that's consistent locally and returned by the scoring mechanics, whatever that's behind how the competition handles it. Because I tried a variety of submissions, and I think all of them errored out, like you were observing as well.
There are, like there's a few sort of different errors you can get. I think you're right though, Jack, in like what you're saying about your problem. I think your problem is different to mine. Like mine was just problems with the values in the submission, whereas yours, like the error you're getting sounds like you run out of resources. I've had that a few times as well. You can stick into your Kaggle notebooks bits of code or whatever to show you what's using up the memory, and then you can use like that.
How do you do that? I've kind of just been like just looking at this panel here.
Now there's there's just like routines you can stick in, and it'll show you exactly which data frames and stuff are taking the most memory, and then use like GC collect or whatever before you do your prediction to free up everything that's not being used anymore.
So like one thing, like I'm quite suspicious of pandas. It's like, do you need to explicitly delete pandas names, or like, I mean, if I'm just overwriting the names, surely that's okay, right? It's not like making extra copies behind the scenes or something, is it?
It can do, like, and that's what's good about these routines I have or whatever. It'll show you exactly what variables are in the scope and like how much memory they're using. So so like here, when you do that, your D set, it's probably pretty big, and then you do the predict target, so you get your target, but your D set will still be hanging around. And
right. So you're saying so garbage collection is the thing to use?
Well, like it's what I tend to do when I'm sort of hitting these problems is just before I do the sort of the final submission, make sure that everything that's not involved in the submission is deleted, just to leave as much memory as possible. Does the notebook run okay just when you save it?
Yes. It runs okay. So I think it's because like there are more samples, like when it's evaluating online or something.
Yeah, so like sometimes as well, like when that happens, it's obviously harder to track down errors during the submission process, because you don't get any logs or whatever to show you what's gone wrong. And so like if that happens, what I tend to do is like double the size of my sort of test set or whatever, so as I can sort of try and recreate it just in the saving process, or in the run process, just sort of put extra load into it.
Yeah, so I'm just like very slowly like narrowing down like the exact bits of code that's causing the problem. But like you need to wait for the, you know, once you make the submission, you need to wait for the outcome to to appear.
Yeah,
and you only
as
have
I say,
5
like
chances.
I had 5 days of that or whatever. So yeah, like each one was taking hours. So
Yeah. So like one of the like problems that I've run into like using this library is that how it handles null values. So like inherently it can handle null values in your data, but you need to, when you create the model, you need to sort of tell it like what the null value is in your input data. So if in your input data frame, the null values are like minus 999, then you need to when you create the model, you need to say, okay, the null value, you need to set this global variable null value equals minus 999. But the problem with this competitions data is that the missing values are in the pandas data frames are sort of NaN, and I'm not sure like what I should set you know, like for NaN, because like NaN in pandas data frames, they are not like numpy.nan. So I can't set no value. I can't say no value equals numpy.nan. That wouldn't work. And I've thought about replacing NaN and fill NA with minus 999. But the thing is, in one of the features, I think it's called VWAP, it ranges from minus infinity to plus infinity. So, I mean, I can set missing values to minus 999. So, so this is kind of tricky.
Yeah, when I was cleaning the data, so like there's time steps missing. So I'd whatever. Yeah, like I had added in the missing time steps, and then because of the fact that it's like the value for the competition is using closing prices. So like if there was like a row that was missing, I would set the opening and the closing and the whatever it is, the high and the low, all to that same closing price. And then because of those time steps being missing, I would set all of the other ones like the volume and stuff to 0.
Okay.
And in that way, I got rid of like all the NaNs out of my thing. Because as I said before, especially like when you're making the submission, if there's any NaNs in there, then the submission will fail. So in that case, I would set them all to 0.
Right.
So Steve, did you fill in all of the missing rows in the training data missing time steps with what you said, meaning some value for the closing price and then zeros for like volume weighted average or other things? Just the closing price value copied over, or some interpolation and then the open, high, low and everything else to 0?
Well, I've actually got like 2 data frames. So I've got one data frame, which is the actual competition data, which you can't add new time steps into that. You can't add the missing minutes into that because of the thing we were talking about before, the 3750 the 3750 rows that you need to calculate the value. If you go and like fill in the missing values there, then your 3750 rows will be different from their competition data, and so you'd end up with different values. So I keep one data set that's untouched in terms of like the time steps and the minutes and stuff, which I use to calculate the values. And yes, like there, I don't think there was any missing stuff in that really. But then I've got like a second data frame, which is per minute data for each asset. And like in that case, then I've filled in all the missing time steps. because I was using it like in a univariate way or whatever to try and predict for each one. And in that case, yeah, like in the missing minutes, I filled the missing values in the way I just described.
Sorry, what are you using the second one for then? The second one where you have filled in the missing?
I was doing, like the ARIMA stuff, and like in it, I was just predicting each asset by itself. So like it was doing univariate stuff, and like within that, it needs to have a frequency of minutes. And so if you've got missing time steps or whatever, then the ARIMA model was moaning about it. So yeah, like yeah, so yeah, because like the competition one that I keep, I only keep the closing prices of it because you don't need any of the other bits and pieces. Whereas yeah, like the minute by minute one, I was keeping all the other information like the volume and stuff, but I haven't got around to using it yet.
Okay, got it. Thanks.
Yeah, so like the one last thing I want to mention is like in this transformers work, they in terms of feature scaling, to scale the year feature, the authors simply took like the minimum, the first year and the last year of their entire data set, and just scaled everything between 0 and 1. But like I wonder like how this would work when during submission we will have test samples from a new year, 2022, and I mean, if I just use the scaling, the year feature, it will go above 1. So I'm not too sure how to handle this yet. So.
When they're using it, are they using it to predict share prices?
Yeah, so like the model is pretty general. You can feed it any sort of features, but by default they only use they don't use any features like the closing price, the opening price. They simply take the timestamp and then predict the targets.
Right.
Yeah, it sounds pretty impossible, right? But like for all the so they did this for a couple of example data sets where like for weather they just take the timestamp and then predict the weather observed at different stations. Yeah, but if you want to, you can also add sort of physical features if you have them available.
What is it you're predicting then? Are you predicting just the actual value for the competition?
So I guess like if this is the present, I can predict 16 closing prices into the future, and then convert that into.
Are you predicting closing prices there, or are you predicting?
So these are actually the actual targets, but I'm kind of predicting future 10 future targets. And
yeah, because like the targets themselves, they always lie within the range ±1, and so your scaling might be okay in that case because it never goes outside that range. You can see there, like you're just along the sort of 0 line. Whereas like if you were predicting closing prices, like then obviously they in theory will keep on growing.
Yeah, actually these are all sort of scaled values. I need to like inverse scale them.
Yeah.
But I think for this competition, I'll probably just predict like one target value in the future. Because yeah, like converting closing prices into target, it's another extra step, and I probably won't have a lot of time for that. Yeah. So in the end, I'll probably just like have like one cross in the future. like for these.
Yeah. Yeah, so like in that case, you may not need to worry about the scaling thing.
You mean for the year? The problem with the year is like, so if our training, if the data we currently have is like from the year 2019 to 2021, then everything within this range is between 0 and 1 after being scaled. Like, how do you handle 2022?
Oh, sorry, I thought you meant that they were scaling like the target between the max and minimum value that they'd seen over their period of their training data.
No, I was talking about the scaling the year feature, like which year the timestamp is.
Right.
Yeah, I just feel like it's a bit.
Yeah.
It's a bit
Can you
weird.
not just expand it then to expand it to the length of the competition?
Yeah, I was thinking maybe that's what I need to do. Sort of, even though the training data I have like right now only goes up to 2021, I'll probably need to set the maximum year to 2022 in view that I would be making predictions in that year.
Yeah, like that's what I've done within my data sets. Like, as I was like talking about a few weeks back or whatever, I was running out of time because of the fact I was like always trying to append to the data set every time I got some new data, which was really slow. Whereas now my data sets, I allocate them all up front, and I've made them so it's like they'll run until the end of the competition. They have like the time steps to the end of the competition up until wherever it is, April or whatever. So
I read in one of the tutorial notebooks on the API that if you iterate through the test set, it would take about 10 minutes. I mean, if you don't make any predictions, if you just iterate through the test API, and yet they say that eventually the training set, the supplementary training set, and the test set, they will form a contiguous set. And yet they say the test set it will take 10 minutes to iterate through. Doesn't that mean that there will be I don't understand why then we need to have like a live submission period if they already know it's gonna be like it will take 10 minutes to iterate through the test set. That's one of the things that's slightly confusing to me, because I would imagine if you had new data coming in, like it won't be just 10 minutes, right? Was it?
Well, yeah, like so at the minute you've got the training set, which takes us up to, I can't remember where the training set goes up to. I think the training set goes up to like September or something of 21, and the supplemental file at the minute basically contains nothing. And then I can't remember what, yeah, like the test set at the minute is like sort of just rubbish as well. But when the competition starts, so I think the training set will stay exactly as it is. It'll still just go up to September 21.
Yeah.
And on the date when the competition starts, the supplemental file will get populated with all of the data between September 21 and the start date of the competition. So the supplemental training and the training file, the two of them join together to give you like all the current training data plus new data, new training data up until the start of the competition. And then after that, then their like API in your notebook, it'll start doing the test set from, what was it, the 1st of February or something, say it starts. And so like at that point, yeah, like it'll work, they'll run your notebook periodically and they'll test all of the data from the 1st of February up until whatever date the notebook's being run on.
Okay. All right. So the test set will keep on growing after the 1st of February, and they'll just run our notebook multiple times.
Yeah.
Oh, okay.
And so, yeah, like I think the competition runs from what, say the 1st of February until the 1st of April, something like that. And so, yeah, so for February, you'll only be being tested on February's data, but by April, you'll be tested on February, March, and April data.
All right, so even though your submission notebook might be working at the beginning of February, like maybe towards the end, like towards the April, it might start to fail if it's too slow or something. Oh, well.
I could see like a lot of people, their notebooks just falling over as it sort of starts to get more and more data coming into it. And like obviously, as you get closer to the end of the competition, you're getting more data, and so like it's going to take longer to predict, and it's also going to take more memory to predict. So yeah, like I can see like a lot of people struggling to have notebooks that actually survive the period.
Right. Yeah. So yeah, that's tricky.
Yeah. So maybe if you just write a simple notebook that manages to survive for 3 months, you might win.
Yeah.
Sorry, one thing I meant to ask you about your notebook there. Is that a multivariate thing? The transformers, are they dealing, so like you said you're putting several fields for each asset in, but you're putting all the assets in at once as well?
So so what do you mean? Yeah, so for the input, yeah, so for the input, you input, say this is asset 0. When you input, you would input these time features. So there are 6 of these. And in addition to these, you also need to input the target. You actually need to input the target value in the past.
But do you just input the 6 features for asset 0, or do you put 6 features for each asset?
So because at the moment I'm only using features from the timestamp, the timestamp is the same for all assets. So yeah, you would just have the same 6 timestamp related features for all the assets.
Right. Okay.
Yeah. Yeah. So and you provide these in the context period in the past, and in addition, for each asset, you also need to provide their target value in the past, like shown here with a blue dashed line.
Right.
All of these, and once you provided these, the model will output these the target values for each asset in the future, in the target period. So you get like the predicted target value for asset 0, for asset 1, and so on.
Okay.
Yeah. But I guess if I want to include also the opening price, the closing price, I will get additional, like features for each asset in the past.
Yeah.
Yeah.
Okay. Anyone else? Want to share? Yes, I mentioned early on, I kind of didn't do a lot of trying techniques, or at least getting successful score. So I'll defer it any attempts I have until next week. If nobody else has anything to share, thanks for joining. Happy New Year to everybody, and hope we can all make some good progress over the next week on the competition. And thanks to Steve for blazing the way to understanding the scoring and stuff, which is, I think, the biggest, at least for me, has been the biggest hurdle in this competition. So see you all next week. Thanks for joining.
Cheers.
Thanks.
Bye.
See you.
Thank you.
See ya. Bye.